Okay, whenever you get ready to do your virtual lab, you'll be in your Google Classroom. There'll obviously be two links here. The video that I'm making now will also be posted here, okay? hmdscience.com is where you're going to go to access this lab. But before you go here, do this first. If this does this to you, if the preview doesn't come up like it's supposed to, go here or just click to open with Google Docs. Okay, I edited the lab report a little bit to make it like I want it for you. So this is the lab report that you need to fill out while you're doing the lab. Okay, so keep it tabbed up here and you can fill this out right on the computer as you're doing your lab. Okay, all right, once you pull that up, go back to your Google Classroom and then go here, hmdscience.com. If you want to, you could even just copy and paste it. Okay, this logged me right in because I log in all the time, but I'm going to go back to this page because this is what you will see whenever you go to hmdscience.com. Remember that your username is your first initial, last name, 20. Your password is wildcats, plural, all lowercase. All right, that's how you get into your website. All right, once you get here, go to resources. Yours says student resources. It's fine, it's the same thing. Now, when you get to this point, you have to change to chapter 4 and hit go in order to get in the right spot. Okay, it's okay if it pulls up your book. You need student resources though. Click on that. Okay. Once you click on student resources, you can go to labs, virtual labs, and it's the only one on there. Okay. Now, once it comes up, what I'm going to do is I'm going to take you through the introduction for this so that when you open this lab, you won't have to do the introduction because I did it with you. So there's some things I want to tell you along the way.
Virtual lab, identifying elements.
All right.
Select lab report now to download a new lab report and save it to your computer or another location.
You do not
need to
do
fill
that.
out this document as you work through the virtual lab.
You do not need to fill out the lab report. You do not need to download that. You already did it. Okay. I changed it some for you. And so you can go back and forth. See, yours is already here. So do not download that. Okay. The arrows down here is how you move forward.
People usually think about volcanoes in terms of the destruction they cause. But volcanoes also build up landforms, such as the islands of Hawaii. Volcanoes bring matter from deep within the earth to the surface. Areas marked by recent or ancient eruptions are often rich in metal ores. The table shows just a few of the metals found near eruptions. You are a member of a mining company's research team. Your task is to analyze some mineral samples to determine what metal elements they contain. You'll need to know about atoms and spectroscopy to get the job done. Click Background to learn more about the chemistry of volcanoes.
Okay, you're good. You don't have to go into all of that. All right.
Atoms are made of protons, neutrons, and electrons. Protons and neutrons form the nucleus in the center of the atom. Electrons are in energy levels outside the nucleus. In many cases, the lower the energy of the electrons, the closer they are to the nucleus. Electrons move to higher energy levels by absorbing energy. Electrons release energy by giving off photons of light when they fall from higher to lower energy levels. Each photon has a specific energy, and that means it has a specific wavelength and appears as a specific color. The human eye sees the combination of wavelengths for the element as a color. Learn more about the Bohr model and Niels Bohr in background.
Okay, we already know about Niels Bohr.
Every element has its own unique set of energy levels. So each element releases a unique set of photons after it has absorbed energy. Elements can be identified by the colors of photons they give off, just as people can be identified by their fingerprints. Substances give off different colors of light when you burn them in a flame. You can observe the color of this light to get a hint about the identity of the element. This is called a flame test. For a more accurate analysis, you can use an instrument called an atomic emission spectrometer to measure all the different wavelengths of light emitted. The color you see in the flame test is the combination of wavelengths for the element identified in the atomic emission spectrometer. Click Background to learn more about how the atomic emission spectrometer works.
Okay, so in your lab that you're going to do, you're going to do a flame test, and then you're also going to get a printout of the spectrometer readout, okay, so that you can compare it to known metals. So that's the two things you're going to be doing, a flame test, and then you're going to compare it to known metals.
In the Perform section of this virtual lab, you can run a simple flame test to help identify the unknown metal in the mineral. First, choose a mineral to test. Drag the hammer to the mineral to collect some powder. Then drag the paper to empty it into the beaker. Next, drag the dropper to the beaker and add some acid to make a solution. Dip the nichrome wire into the beaker and then drag the wire loop into the Bunsen flame. Observe the color change. Record the color and compare your results to a list of some elements and their flame test results. When you have done that, you use the atomic emission spectrometer to generate a detailed spectrum fingerprint of your sample. Then you can compare it to a sample of spectra from known metals to be sure of the identification. In your lab report, record the answer to the question on the next screen.
Okay, so once you get into your lab, you of course will have access to all of these tabs. You can go straight to Perform if you've watched this and you feel good with the procedure and you have no questions. If you have questions about the procedure or can't remember what to do, you can either look in your lab report, okay, because the procedure is also in here. There it is, okay, or you can click back on this tab Plan and then go back and look at this again. Okay, so you have options if you can't remember the procedure, but what you can do is whenever you get into your lab, you can go straight to Perform if you remember your procedure.
To identify an element, you can use a flame test. Answer this question to check
you
your
don't need to
understanding.
answer that.
You place a sample of a chemical substance. You brought 3 mineral samples into the lab to test. Click one of the 3 samples to test it.
Okay, so you don't have to answer that last question that was in the plan section. You do, you've already watched what you need to watch for the procedure. If you get into your lab and you have questions about it, just tab back to here and it will go over it again.
Lab,
okay.
You brought 3 mineral samples into the lab to test. Click one of the 3 samples to test it.
Okay, but you don't have to. You can go straight to the Perform section, select a mineral, test it, compare your results to the spectrometer, and then just make sure,
use the equipment to prepare a sample and perform a flame test.
Make sure that your simulation is running well. If any of this stuff starts running slow, just let me know and you may have to log out and log back in. See how this is going really slow? This should not be a slow process. And it doesn't always go really slow. Sometimes we have to log out and log back in. Okay, so that's obviously step 1. Step 2, and then what you're going to do is,
that won't help
sorry,
you
I'm
with
not
your
going to do it,
analysis.
okay? You can do it when you get there.
You now have a spectrum for the atoms of your unknown element. The lab has a record of the spectra for some known elements.
Okay.
Compare the spectrum of the unknown metal to the elements in the spectra library.
Okay. After you have done the Perform section and you do the flame test, it will give you a printout right here of your mineral, and what you will do is you will compare it.
Observations in your lab report.
You will compare it to known ones. So like there's calciums, there's what coppers looks like, there's potassium. So you'll have yours here. After you do your flame test, it'll show up right here. And you can compare it to this one and pick which one you think it is based off of your spectrometer results also. Okay, so you need to do each mineral. You've got 3 here. You need to do each one. So after you've analyzed, you've gone through and you've picked which one you think it is, go back and then do the other one. So you'll do 3 trials total, 1 for each mineral. Okay, as you do them, you have a table here where you're going to record them. Okay, color, likely metal, other observations. What else did you see? Okay, you've got questions down here when you get done doing all 3 of them. And I think that's all you need. I don't think you need anything in conclude. You'll take care of all this in your lab report. So you don't need any of these last 3 tabs. Okay. I've already went through the problem with you. I've went through the plan with you and the steps. When you get in your lab, click perform, go ahead and do the flame test, analyze, pick which one it is, and do it for all 3. Okay, hmdscience.com is where you go.